Hope you checked out the dilation review video, and now we're on to the main event, identify similarity. All right, so what we're going to do is we're going to be using transformations to prove that these guys are similar, to prove that shapes are similar. We know that similarity only happens if during a sequence of transformations we have at least one dilation. So we can flip, rotate, and translate things. But to get similar shapes or same shape, different size, we need a dilation. All right, so let's go here. Example 1, determine if the two triangles are similar by using transformations. So you have to describe the transformations that would get this triangle to sit perfectly on top of that triangle. All right. I do not like the example, the steps that they take. This step here should be step 2. We can figure out the translation after we figure out if they're similar. Why bother with this if the shapes aren't even similar? All right, so we are going to test for similarity first by using our two characteristics of similar shapes. Characteristic 1, corresponding angles are equal. All right, and they look equal. But the real one that will help us, and we can determine it mathematically if they're similar, is by taking corresponding side lengths and seeing if they're proportional. All right, so we're going to check, basically make a fraction of these corresponding side lengths and compare it to the fraction of the other corresponding side lengths, like these guys down here. All right, so this is what they did for their step 2, but we're going to make it step 1. First things first, check to see if they're even similar by checking the ratios of corresponding side lengths to see if they're equal. All right, so they took HG and put it over ED, the length of HG, and then put it over top of this. Now, I haven't been focusing on which one to put on top, but you'll want to write down here that the lengths of the new shape, okay, we call that the image in math, right? The old one is the pre-image, the new one is the image, all right? We put the lengths of the image on top, all right? So the new shape lengths go on top. The reason is because then you can get the scale factor by dividing these two. What multiplied by the old to get the new? Well, we can see that scale factor is 2, or that it's doubled. Okay, so anyway, back to what we're talking about is the ratio of corresponding side lengths with the new one on top gives us 8/4. Now let's see if that ratio is equal to the other ratios of corresponding side lengths. So next we'll check GI and DF, and we count them up 1, 2, 3, 4, 5, 6, and 1, 2, 3, and that gives us 6/3 or 2/1. So far so good. We've got similar shapes. Now, how'd they get this 10 and 5? Because you can't really count diagonal lines on a grid paper. If you said Pythagorean theorem, then you're onto something. All right, probably just plugged in the legs, squared them, added them, square rooted, and got that, like we've done with Pythagorean theorem. So you would want to do that if they don't do it for you, but basically you get 10 and 5 and divide it and you get 2/1. All right, so look, we've proven that these are similar shapes, and we've seen that the scale factor is 2. All right, now what you're going to do now is you're going to have to describe, right, because this up here says determine by using transformations. So we're going to describe what transformations would get this blue triangle to map on top of this green triangle. And basically you're going to say, well, we have to enlarge it by dilation with scale factor of 2, and then slide it on top of the other one. So a dilation and a translation. It's funny because they're in the book, they're very specific about the translation, but then they don't give any specifics about the dilation. So very weird. I would always describe the dilation first, and then I would describe the translation. So it's really not a great way to describe it here. I would describe, okay, let's dilate it from point D. Okay, so a center of dilation here by a scale factor of 2. And so that would give us, let's see, that's 3. So double it would be 6. right? And this is 4, so if we double it, it's going to be 8, which is going to protrude up above there, but not letting me draw up there. Oh, here we go. And now I lost my pen. All right, so that gets us right up there. Okay, and now we can determine, so scale factor of 2 from point D, dilated by a scale factor of 2 with the center of dilation of D. And then we're going to take that, sorry, I'm not very good with my trackpad here. We're going to take that whole thing and slide it on top. So we can say, looks like a translation that would move us down 2 and over 1, 2, 3, 4, 5 to map it right on top. So all corresponding points sit right on top of each other. Okay, so that would be the specific way to do that one, whereas these guys don't go so specific on the dilation. All right, number 2, we have to determine if the two rectangles are similar using transformations. So we have to describe them again. They take this all out of order, because why would we go through the challenge of rotating something if we don't even know if it's similar yet? So let's prove it if it's similar. So get that out of there. Now that's going to be step 2, if we even need it. We might not even need it. Okay, and this is step 1. Determine if they're similar first, then if they are, then you can go on to rotating and flipping or whatever you got to do. All right, so here we go. Let's find the corresponding sides. It looks like they say that WT is corresponding with XY. XY, where's XY? There it is. XY. Okay, so we're just going to check out those lengths. All right, and 5 to 7. Then we'll do, let's check out TU, and YZ. All right, and check out those lengths. And right away, you can see that we've got that and we've got that. Are those equal? No, so the ratios are not equal, so the two rectangles are not similar since the dilation did not occur. That just means, okay, they don't fit the similarity rules, so this one is not gonna work. So we just say, determine if the two rectangles are similar. We say they're not similar because a dilation will not get you from the one shape to the other. All right, so check out that first. Now look, we don't even have to do this step because we've already proven that they're not similar. All right, so there you go. I'm just trying to streamline it for you so you don't get confused with unnecessary steps. All right, let's look at the next one. Okay, you can practice these, pause, practice them, see if they make sense to you. But remember, first step is to try to figure out, which are the corresponding side lengths, make a ratio of those, and check to see if there's a if they're proportional. All right, so pause, do them, and then get back to them and do your and check and see what questions you have or what problems you had, or if you're awesome at it. Okay. All right, I'll just quickly check these out. So if we check, we can see which parts of these are corresponding. All right, it looks like this corresponds with this. And notice that we have 1, 2, 3, 4, 5, 6. So that'd be 6 over its corresponding side would be 3. All right, and we're going to check to see if that's equal to the other one. So let's go with this corresponds with this guy. So let's go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5. Oh, hey, look at that. 10 over 5, they are they're equal fractions, so they're proportional. So bingo, we have similar shapes. Now, it looks like a scale factor of 2. And if we go from point T, that's gonna double that, so that's gonna go up to S is going to be, instead of 3 away from T, it's going to be 6 away from T. And then U is going to be, instead of 5 away from T, it's going to be 10 away from T. Somewhere over here, we got our shape. And then what other transformation would we need to map that orange triangle that I drew onto this green one? Well, we would need a reflection over this line, wouldn't we? So you can draw in that line of reflection and flip that over there, and boom, you got similar shapes mapped right on top of each other. So we've used transformations to show similarity. All right. So there you go. There's an example. And then you can see B, if you make these ratios, okay, they said AB compared to EF, that's 3:2, and then AD compared to EF. And you can see that's 5:4, so they are not similar anyway. All right. So here's a little review. Use scale factor. If we are finding that you got something smaller than the original, then it's going to be a scale factor between 0 and 1, because multiplying by some sort of decimal or fraction between 0 and 1 is going to shrink something, shrink the numbers. Equal to 1 gives you exactly the same as the original, because 1 times anything is that number. And then a number greater than 1 as your scale factor is going to enlarge the shape, okay? I think you can read through this and be fine with it. I'm not going to take time to do the video, but we're hopefully going to be okay with this, so we can move on to our next lesson tomorrow, or actually tomorrow's break, so Wednesday. All right. Answers are still on, right? So you can check your answers on this next problem, which is your got it. So try the got it. See if you have any questions. Thanks for listening. Good luck.